to the section on calculus. Again, the point here is that we want to get you to the start. I'm not going to type in every command, but we'll walk you through it. But again, at this point in time, you probably should be able to do this without the walkthrough. The first thing I'm going to do is I want to open up the terminal, and I want to launch Sage. Now, I can't remember what the path is, but since I use Sage so often, once I hit the up arrow, it's immediately there, right? Again, if you can't remember that, you'd go to the Application menu in the Finder, double-click on Applications, and open up Sage, and you could launch a terminal app doing that as well, all right? Let me close that out, go back to this, hit Return. Sage is launched, and let's go back, and let's take a look at these calculus commands. The first thing to do is defining some functions over here. So f of x is a function. It's being assigned x star. That's the exponential Euler's number to the x power. And they define another function. They find g of x. And g of x is being defined as x squared star cosine of 2 star x. And they define another function called h of x. And that is going to be a quotient, a rational function, x squared plus x minus 2 divided by x minus 4. All right, so let's take a look. First thing, kind of simple things, evaluating a function, displaying the functions, yada, yada, yada. Of course, we want to get to some calculus stuff, and limits are a good place to start. So limit, the limit of the function f of x as x goes to 1. All right, it says it's e. All right, you do these things by hand as well. And yeah, looking mixed over here, it's not too bad. I want to do h though, and limit. Here's a point to this. H as x goes towards 4. It's actually an incorrect answer. And what I mean by that, if you looked at the graph of it, it's actually going to, from a certain side, to plus infinity, from this side going to minus infinity. All right? So what I want to claim over here is I want to certainly encourage you to read it, but a direction. Let's take a look at this over here. And I'm going to say the direction now, dir. The direction I should approach 4 is from the right side. That says plus infinity. And I want to do the left side, see what happens on the left side. So it's minus infinity. So the limit is actually, as x approaches 1, does not exist. All right, they're not in agreement. By the way, also infinity and plus infinity also does not exist, but we like to list them as plus or minus infinity. All right, derivatives, fairly straightforward. Let's just take a look at an example. And, FP, I wonder what FP stands for. F prime. All right, I'm just making that up, by the way. Equals, you can call it anything you want. Derivative, D-E-R-I-V-A-T-I-V-E. And I want to take the derivative of f with respect to x. Let's display FP, see what it looks like. All right, kind of what I was expecting. So forth and so on. All right, so let's talk about defining a variable now and taking a derivative with respect to a different letter. So let's define y as a variable. And let's do the derivative of f with respect to y now, see what happens. Now, since f does not involve a y in it, the derivative should be 0. Let's display fp, and I get 0. All right, to get the idea. And what I want to do is now, let's do HP now, okay? HP equals derivative of h with respect to x. And what I want to do now, solve HP of x for 0. It's something you do in calculus a lot. Pretty simple. All right, so forth and so on. Or here's another good one, find root. Oh, you've seen that before, right? Why would we want to do that? Something that's really tough to, solve an equation exactly, but finding a root's not a bad idea. You should have an idea where they are approximately though before you do that. All right, take a look, see if we get to something that's maybe a little more interesting. Let me get the integrals. All right, let's display f again for you. And we're going to integrate. And we're going to integrate f of x with respect to x. All right. So forth and so on. Derivative of an integral with respect to x. Again, I would definitely look at the commands, type them in, see what comes up. Let's define a function y of x as equal to the Euler's number to the minus x squared. Integral the function y with respect to x. And it returns something that might look confusing to that error function, right? That's an integral that probably your calculus teacher is telling you can integrate. It doesn't have elementary function, by the way. Here's a definite integral. So we're going to integrate f with respect to x on the interval from 0 to 1. And it gives me the number. All right, more integrals. Numerical integration. All right, sometimes you can't do an integral. For example, let's just do integral. And what I want to do is, I guess we did that function y, right? X, and let me do it between, I don't know, minus 0.89 and 0.98. I'm just making that up, by the way. All right, you see you get an answer there, and certainly if I want to do a numerical integral, right, let's do that. And I'm going to just type this in here. I copy paste. All right, get an approximation. They're not less than a square root of pi down, by the way. Get the idea. Then there's some exercises for you to work through. I do recommend you work through those exercises. Try to make sense out of it. All right, also want to point out when you're doing these things over here, you may want to consider by going the directions left and right, as your calculus teachers would tell you to do that. This over here, right-sided limit, left-sided limit, taking derivatives. I noticed there's a footnote over here. This function had been taught with respect to t. You have to define the variable, by the way. And again, you should be getting much better at using Sage to do these types of problems over here. However, I do list out my code for these examples. All right, thank you for paying attention.